Hello class, this is the solution for the part 2. Let us try to go through them together. Here the first question. Statement, it says x is a multiple of 3 and the connecting word is the word and. X is an even integer. It's true. Now, how can you have this one to be true? Then x has to be even integer at the same time multiple of 3. Now, we realize that 9 is a multiple of 3 but not an even integer. But in fact 6 is. So therefore the answer would be choice number 4. Alright, let us look at number 2. Here, which statement must be true? When you're looking into these three letterings in congruent triangles, you see that technically speaking, A has to be corresponding to X. So it's B to Y and C to Z. Now then angle C must be congruent to angle Z, not Y. But angle A must be congruent to angle X. Angle A to angle X. And they look about the same too. But more than anything, the lettering should give us the clue. Alright, so therefore, choice number 2 would have been our answer. Alright, let us move on to the third question. Here we have AT is 5. Now TB is 7. And AV is equal to 10. Now what is the length VC? Now we realize we can try to go for 5 to 10 to 7 to x, but rather than that, what I like to do is remembering the corresponding size. You see, the entire thing is the corresponding size of the big triangle compared to the small one. So the proportion in which we're going to write is 5 to 12 is equal to 10 to 10 plus x. You see? Now, then when we cross multiply, then we get 120 must be equal to 50 plus 5x. And here we get to realize 70 must be equal to 5x. And the value of x becomes 14. So therefore, 14 becomes our answer. Alright, next, number 4. Here we have, in fact, by looking at the sketch, this is the angle bisector. You see the angle, arc has been drawn. So this is angle bisector. Construction. That means this angle must be congruent to that angle. Now here, one thing, which statement is false? ABD, is that equal to DBC? DBC, that is correct. How about half of ABC, which means half of the entire angle is ABD, which is also correct. Now, 2 times of DBC, 2 times of this small angle is equal to entire angle, which is correct. 2 times of big angle is not, in fact, equal to small angle. So therefore, choice D would have been, or choice number 4 would have been our answer. All right, the next. Here we have, this is 80, this is 30. But in fact, you will realize that this x is same as this x by corresponding angles. So we get to write this one as an x. But in fact, since this line is a straight line, we get to realize 30 plus x plus 80 must be 180 degrees to make a straight line. And here we get to realize that x must be equal to 70. So choice 3 becomes our answer. Right, here we have, you see this is the classic exterior angle. This angle must be sum of these two angles. Now, not only that, that's right, angle ABC must be equal, not greater, equal to angle C plus angle D. Or another way of looking at this, exterior angle is greater than any one of the two angles. So therefore, our correct answer here becomes choice 3. Alright, here we have AC bisects angle BAD. So that means what's actually being bisected is this entire angle. So this portion of the angle is equal to this portion of the angle. Now, angle B is also congruent to angle D. And guess what? The line segment AC is common in both, reflexive. So therefore, we get to realize angle side. Choice number 4 becomes our answer. All right, so here we have angles and the ratio of 2 to 3 to 5. Now then, whenever we see the ratio, then we can write it as 2x plus 3x plus 5x equals to 180. Now, once you solve this, then you will realize that x must be equal to 18. And if x equals 18, then the first angle becomes 2 times of 18. Yes, it becomes 36 degrees. Next one, 3 times 18 becomes 54. And then third one, 5 times 18. Oh, in fact, it becomes 90 degrees. Haha, because of this one, we get to realize that it's a right triangle. Now, what is the measure of each interior angles of the regular hexagon? Now, hexagon, interior angle, sum of the interior angle would have been 180 times 6 minus the 6 because of the hexagon, but divide by 6 for each interior angles in a regular hexagon. Then here, we end up getting, this becomes 120 degrees. All right, number 10. As shown in the diagram below, so given in this way. Now this is equal to x, this one is equal to 7, and then this one is x plus 1. Now what is the measure in inches of the vertical support bar? So here we have vertical support bar is this one. Now those of you who memorized the Pythagorean triple ratio here, 7 and then x plus 1, in fact, this will be 24 and 25. But if you didn't memorize it, then you actually have to calculate one at a time. 7 squared plus x squared will be equal to x plus 1 squared. Then here we have 49 plus x squared. If you expand this one, you will get x squared plus 2x plus 1. Then here x squared cancels out, and then subtracting 1, we get 48 equals 2x, where x being equal to 24. So here it becomes 24, therefore the vertical bar is 25. Choice number 3. All right, using a composite strategy, construct a perpendicular bisector of AC. Perpendicular bisector, first what we need to do is we gotta bring a compass and then come more than halfway and draw an arc. Likewise, do the same without changing. Oops, I guess I went a bit too short. So what I'm going to do is I'm going to extend this one just a bit more and then draw an arc. And here we have, now with that intersection, using a ruler, and there it goes. We get to have perpendicular bisector of AC. All right, let us move on to the next question. Here we have angle ACB. ACB, this angle, is in fact congruent to AED, that angle. Not only that, this angle is reflexive. So therefore, no wonder the big triangle ABC and the small triangle ADE, they are similar to each other. So first, this will be the statement. This one will be the reasoning. First, given ACB is congruent to angle AED. Why? That's given. Number 2, angle A is congruent to angle A. It will be reflexive. In fact, we have done two pairs of the angles. So therefore, triangle ABC is similar to triangle ADE by AA. Alright, that's it. Number 13. Here we have HJ is congruent to JK. Now that means if this one is 70-degree angle, and I call this one as X because of an isosceles triangle here, we have 2X plus 70 must be equal to 180. And here you'll realize that X will be equal to 55. Now, if this one is equal to 55, and knowing the fact that 55, this angle is the exterior angle of this triangle on the left side, where this one is 28, let me call this one as A. Then we get to realize 28 plus A must be equal to 55. And our question here, we get to realize that angle A, then therefore, will be equal to 27. Now, since angle G and angle GKH are not the same, therefore, triangle GHK is not an isosceles triangle. All right. Now, number 14. Here we have similar triangles. Determine the length of AB. AB will be X. So here we see the corresponding relationship here. X over 4. This one to that one is equal to X plus 2 over X plus 6. Now when we cross multiply, then we get to realize 4X plus 8 must be equal to X squared plus 6X. Now bringing everything onto one side, we get to realize 0 equals X squared plus 2X minus 8. That means we have X plus 4 or X minus 2. Therefore, the values of X becomes X equals negative 4 or 2. Of course, we cannot have negative value for the length of the side of the triangle, so therefore X must be equal to 2, which is equal to line segment AB. Alright, that's it. So have a great day and see you later. Bye-bye.